Alright, it's lesson 9.9 today, and this is actually a continuation of the ratio test topic we learned in lesson 9.8, where I introduced you to two terms, one called the interval of convergence, and one called the radius of convergence. So I gave you a quick definition at the top here. The radius of convergence of a power series is really the distance from the center at which the series will converge. So if you think about the series centering at some value c, and let's pretend that it goes from here to here, right? The radius, of course, is this distance from c to actually either end, right? That's the radius. Whereas the interval convergence is the range of x values within which the series will converge, meaning all the stuff from here to there. Okay? So let me just show you some examples and you'll probably get the idea. So find the interval convergence and the radius convergence for the following power series. Look at number 1. I see exponents. So you might be thinking, oh, let's do the ratio test. And I'm thinking, good on you, because I think the same thing. So if I do that, let's take a look. The limit of n approach to infinity, absolute value of the next term, so 2 to the power n plus 1, times x to the power n plus 1, all over n plus 1. And yes, we're going to divide by the original, which is the same thing as multiplying by the reciprocal. So let me just write that down. And just like what we did last time, we need to simplify this. And because I told you this converges from the ratio test last time, I know that this must be, you got it, less than 1. Okay? So as I simplify, I think I just get a 2. I get a, what, x. So really I have here 2x times the limit of n approach to infinity of n over n plus 1. And of course I know that that by the n behavior model is just 1. So really ultimately here I have absolute value of 2x is less than 1. And if I want to write that as an interval, I can write it like this. Negative 1 is bigger than 2x, which is less than 1. And solving, I can then say, yeah, x must be between negative 1/2 and positive 1/2. Okay? Now remember last day too, when I talked about interval of convergence, less than 1, I guaranteed it converged. But what happens when the ratio test gives me the ratio equal to 1? Right, it was inconclusive. So in this example, I haven't really figured out what happens when x equals, well, not x, when the ratio here equals to 1. Well, when the ratio equals to 1, that's really just these endpoints. So what you need to continue to do here now is actually check the endpoints. Okay? I need you to check what happens when x equals to negative 1/2. I also need you to check what happens when x equals to positive 1/2, so that we can determine if the endpoints are also places where it converges. So let's take a look at the one on the left, x equals to negative 1/2. That means I'm going to stick this into my original expression here. That gives me the sum of n equals 1 to infinity of, what do I see, 2 to the power n, negative 1/2, that's just negative 1. So I think we get negative 1 to the power of n over n. And this should be an interesting series that you've dealt with before. Negative 1 to the power n, terms seem to alternate. 1 over n, yes, terms decrease. And then I should check the limit as n approaches to infinity. 1 over n, that becomes 0. So all that stuff, right? What does that mean? So I guess once again I can say, yep, terms alternate. I could also say absolute value of the terms decrease. Remember what test I'm doing right now? Yep. Alternating series test. So it satisfies all these terms, and I'll say by the alternating series test, AST, this converges. Okay? And then what about x equals to 1/2? I better check that one, so I'm going to plug that back into the original as well. Sum of n equals to 1 to infinity. This time I just get 1 to the power n, which is 1 all over n. This, I think you know, is the harmonic series, or the p series, where it equals to 1. So therefore, this one diverges. Okay? So after all this work, after all this work, now you can answer the question. So the interval of convergence, which I call the IOC, is actually the value of negative 1/2, but I'm going to put a square bracket around it because negative 1/2 also converges, so square bracket, and then a round bracket at the 1/2 because at 1/2 it diverges. Okay, so that, my friends, is the interval of convergence. And if I'm looking at the radius of convergence, well, notice the center here is at 0, so hopefully you can see that the radius of convergence. And do you know the short form for that? Yeah, I should have just said rock, right? Radius of convergence is just, yep, 1/2. Okay, so can you try number 2? Uh, yeah, go ahead. I think you can. So pause, come back when you're done, double check your work with mine. X plus 1 to the power n plus 1, 2n plus 1, 2 over n, x plus 1 to the n, less than 1. X plus 1 over 2, I think is what we have left over after all that stuff. I guess I don't even need that limit and approach to infinity anymore because I skipped a whole bunch of steps there. Nonetheless, that's what you got. I will continue on. There's 2. Subtract 1. Cool. And then yes, 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 we should check the endpoints. Negative 3 plus 1 is negative 2. So this becomes the sum of n equals 0, infinity, negative 2 to the n over 2 to the n. That just really simplifies to the sum of n equals 0 to infinity of negative 1 to the n. That definitely diverges, right? Because it alternates between positive 1 and negative 1, so I can't really figure out what this actually simplifies to. So diverges, but if you're looking for a reason, I could use the nth term test. And I know that when I take the limit, it does not equal to 0. Okay? And if you use x equal to 1, 1 plus 1 is 2. Interesting enough, you have this now. 2n over 2n, which just becomes the sum of n equals 0 of infinity of 1. Yeah, 1 to the power n, I guess. 1, whatever. This one also diverges by the nth term test. Cool. Now, if you did all that, great. You can then finally say that the interval of convergence is just negative 3 to positive 1, and the radius is, yeah, cut it in half, right? Distance from negative 3 to 1 is 4. Half of that is 2. There you go. Now, I must say this to you. There was an easier way. Yeah, there was. If you could spot this and see that this is really the same thing as x plus 1 over 2 to the power n, so this must be the common ratio. It's a geometric series with a common ratio of x plus 1 over 2. And if you knew this was a geometric series, you knew that the absolute value of r, which would be the absolute value of x plus 1 over 2, had to be less than 1. And boom, there you go. And from here, you could have also said that, and yeah, the interval of convergence you can solve, and the radius must be 2. Knowing that this is a geometric series, guess what? Didn't have to do these things down here. Because I know that when r equals to 1, this diverges. Okay? All right. 2 more examples for this one, and that's it. Okay? Um, you can try this yourself if you want, or you can follow along with me, but we're once again going to just use the ratio test here, the idea, to help us solve. So if you're comfortable with trying it on your own, go right ahead. If you're not, I will do it for you. Okay, here we go. Limit n approach to infinity. N plus 1 infinity over n. Oops, n plus 1. Yeah, I should have got this right. Times x to the power n plus 1. And then dividing by, I guess, n factorial, x to the n. This has to be less than 1. We'll simplify, and I think you just get n plus 1 times x. And the limit of this going to infinity is less than 1. Interesting here, though, is, excuse me, as this goes to infinity, this whole thing goes to infinity. So what does that mean? Is there any value of x here which will make this less than 1? Yes, only for x equaling 0, the statement above is true. Because no matter how big I get, times by 0, it's going to be 0. So therefore, for this one, the interval convergence is really just itself one number, 0. And of course, the radius is, you got it, 0. Weird, eh? Weird. Okay, and then our final one. Let's see if this one's also weird. If you did it already, you might already have the answer. So once again, negative 1 to the power 2 n, don't need to worry about that, because it's absolute value. X to the power 2n plus 1, so that's 2n plus 2, divided by 2n plus 2 factorial, multiplied by the reciprocal, so 2n factorial, x to the power 2n. And once again, this has to be less than 1. Now as I simplify this, let's see what happens. Limit n approach to infinity. I think I have here x squared. And I think in the denominator I have 2n plus 2 times 2n plus 1. Remember, these are factorials, right? So 2n plus 2, if you're not too sure, factorial just becomes 2n plus 2, then 2n plus 1, then 2n, and so on and so on and so forth. And guess what? That just simplifies because that cancels out with the 2n factorial. So that's what we're left with. And now I'm going to ask you what this equals to when n approaches to infinity. Well, when n approaches infinity, when I plug it in here, that becomes really big. So anything squared divided by something huge actually becomes 0. And is 0 less than 1? You bet. It's always true. So therefore, my interval of convergence, yeah, it's actually every x value. And therefore, my radius in this case is also infinity. So 3 and 4 are some weird examples, but hey, it can happen. All right? Now, just note here, in lesson 9.1, we found intervals of convergence of geometric series. Okay? And it was not necessary to check endpoints because I know that when r equals 1, a geometric series diverges. Right? See example number 2. However, the ratio test was inconclusive when the ratio was 1. Okay? So therefore, when we're using the ratio test to find intervals of convergence, you definitely need to check the endpoints using one of the other tests. Example number 1. Okay? Now, if they just ask you for radius convergence, don't worry, you don't need to test everything else because you just want to figure out the range or the distance from the center. But if they ask you for the interval convergence, you definitely need to check whether the endpoints are included or not. All right, that's it. Time for you to try questions from assignment 9.9. And then you are so close to the end. Just one more video and the longest unit ever is done.